In modern warfare, being unseen is often more powerful than being unstoppable. For decades, the United States has pushed the boundaries of stealth technology, transforming aircraft from fast, powerful machines into nearly invisible predators of the sky. But stealth didn't begin with the aircraft most people think of. It started with experimentation, theory, and a few very unconventional designs. The journey begins in the 1960s, and the first aircraft to quietly explore this concept was the Lockheed A-12 and its successor, the SR-71 Blackbird. Although they were famous for their extreme speed, flying at over 3 times the speed of sound, they were also pioneers of stealth concepts. Their design featured sharp blended edges along the fuselage, known as Chinese, which helped deflect radar waves away from their source. Even more interesting, their fuel contained radar-absorbing materials, meaning the aircraft actually became less visible as it flew and burned fuel. This wasn't true stealth as we know it today, but it was the foundation and the first realization that an aircraft's shape and materials could influence how it appeared on radar. By 1977, that idea evolved into something far more radical. Under deep secrecy, a strange, diamond-shaped aircraft called the Lockheed Have Blue, nicknamed the Hopeless Diamond, a reference to the famous Hope Diamond, took to the skies. It looked nothing like a traditional aircraft, and that was intentional. Engineers had discovered that flat surfaces, known as facets, could scatter radar waves in controlled directions, dramatically reducing the chance of detection. But there was a problem. The Have Blue was so aerodynamically unstable that it couldn't be flown by a human alone without computers constantly correcting it. This gave rise to stealth's most critical technology, the fly-by-wire control systems. What it proved was revolutionary. Stealth was achievable, but it would depend on computers as much as aerodynamics. A few years later, another secret project took a completely different approach. The Northrop Grumman Tacit Blue, often nicknamed the Whale, explored whether smooth, curved surfaces could also achieve stealth. Instead of bouncing radar away with sharp angles, Tacit Blue used mathematically precise curves to control how radar waves interacted with the aircraft. It also tested low probability of intercept radar, allowing it to scan for targets without revealing its own position. Tacit Blue demonstrated that stealth didn't have to rely on jagged shapes. With the right calculations, smooth designs could be just as effective and far more practical. With the success of Have Blue, stealth moved from theory to reality. The result was the world's first operational stealth combat aircraft, the Lockheed Martin F-117 Nighthawk. Introduced in the 1980s, the F-117 was officially called a fighter, but in reality, it was a precision strike bomber. Its design relied heavily on fasting because computers at the time still lacked the power to calculate radar reflections on curved surfaces. The result was an aircraft made almost entirely of flat panels, giving it its distinctive angular appearance. Despite its odd shape, the F-117 proved devastatingly effective in combat, particularly during Operation Desert Storm, where it struck heavily defended targets with remarkable precision and minimal losses. For the first time, stealth had moved from theory to battlefield reality. As computing power improved, engineers were finally able to revisit the idea of smooth, continuous shapes derived from the Tacit Blue. This led to one of the most advanced aircraft ever built, the Northrop Grumman B-2 Spirit. Designed as a flying wing, the B-2 eliminated vertical stabilizers entirely, which was one of the largest contributors to radar visibility. By removing these surfaces and blending every part of the aircraft into a smooth, continuous form, engineers created a bomber that could penetrate some of the most heavily defended airspace on Earth. The B-2 combined shape, materials, and electronic suppression into a single system, making it extraordinarily difficult to detect. The B-2 didn't just evade radar, it practically disappeared. However, this level of stealth came at an enormous cost, with each aircraft priced at $2 billion. In the 1990s, stealth technology entered a new phase with the Advanced Tactical Fighter Competition. One of the most fascinating designs to emerge from this program was the Northrop Grumman YF-23 Black Widow II. Unlike its competitor, the YF-22, the YF-23 prioritized stealth and speed over maneuverability. Its sleek, diamond-shaped wings, V-tail configuration, and deeply buried engines made it exceptionally difficult to detect, both by radar and infrared sensors. It was faster and, in many ways, stealthier than its rival, but it ultimately lost the competition. The deciding factor was maneuverability, the ability to outfight an opponent in close combat. Even so, the YF-23 remains one of the most advanced stealth designs ever created, and many of its concepts continue to influence modern aircraft. The winner of that competition was the Lockheed Martin YF-22, which would later evolve to the F-22 Raptor. It's widely considered one of the most capable air superiority fighters ever built. The F-22 combined stealth with supercruise, the ability to fly at supersonic speeds without afterburners, and thrust vectoring, which allowed for extreme maneuverability. Unlike earlier stealth aircraft, the F-22 didn't just avoid detection. It could engage and defeat enemy aircraft while remaining difficult to track. However, this performance came with challenges. Its stealth coatings were complex, delicate, and expensive to maintain, highlighting the need for a more practical approach in future designs. That practicality came with the Lockheed Martin F-35 Lightning II. Designed as a multirole aircraft, the F-35 introduced a new generation of radar-absorbing materials embedded directly into its structure. This reduced the reliance on fragile external coatings and made the aircraft easier to maintain in real-world conditions. Beyond stealth, the F-35 is also a powerful data fusion platform capable of gathering and sharing vast amounts of battlefield information in real time. It represents a shift in focus from pure performance to a balance of stealth, versatility, and networked warfare. Now, the next generation is taking shape with the Northrop Grumman B-21 Raider. While it resembles the B-2 at first glance, the B-21 incorporates decades of advancements in materials, manufacturing, and digital design. It features seamless surfaces to minimize radar reflections, next-generation coatings, and a fully digital architecture that allows for rapid upgrades. The B-21 is not just a bomber. It is designed to operate as part of a larger connected system capable of adapting to evolving threats. Stealth technology is expanding beyond manned aircraft. The Boeing MQ-25 Stingray brings stealth-inspired design into an entirely new role: unmanned aerial refueling, using features like a buried engine and a V-tail configuration to reduce its visibility. It shows that stealth is no longer limited to fighters and bombers. Then, there are the aircraft we know very little about. The Lockheed Martin RQ-180, often referred to as the White Bat, is a highly secretive high-altitude reconnaissance drone believed to operate deep in contested airspace with advanced stealth capabilities. The Boeing MQ-28 Ghost Bat represents a new concept entirely, a loyal wingman drone designed to operate alongside manned fighters, extending their reach and enhancing their effectiveness. Looking ahead, the future of stealth lies in the hands of the Next-Generation Air Dominance program. Early concepts suggest tailless aircraft designs to achieve all aspect stealth against increasingly sophisticated radar systems. These aircraft are expected to integrate advanced materials, artificial intelligence, and autonomous systems, forming a network of manned and unmanned platforms that operate together seamlessly. From the early experiments of the Blackbird to the cutting-edge systems of today, American stealth aircraft have evolved into something far greater than invisible planes. They are tools of information, dominance, precision strike, and strategic control. And as technology continues to advance, the true limits of stealth remain unknown. However, for the most stealthiest aircraft, chances are we don't even know they exist yet, because the most advanced aircraft in the sky today may be the ones no one has ever seen. Thanks for watching. Remember to like and subscribe, and we'll see you in the next one.